Hello my friend, welcome to my channel. So today I'm going to solve a problem related to the hypothesis testing for population mean. So here I'm going to talk about the less than case. In the previous video I discussed about the greater than case. So as you can see, a researcher claims that average cost of men's athletic shoes is less than $80. He has selected a random sample of 36 pair of shoes from a catalog and found that the sample mean is $75. Is there enough evidence to support the claim at alpha equals 0.10? Assume the population standard deviation is equals 19.2. So let's write down the hypothesizes, null hypothesis and the alternative hypothesis first. The alternative hypothesis is the claim here. The claim is this: the athletic shoes, the cost of men's athletic shoes is less than $80. So the population mean notation is mu, is less than $80. And the null hypothesis is the equal $80. So now we have the two hypothesizes, and let's look at the some information here. The sample size equals 36 and the sample mean x bar equals 75 and the standard deviation of the population is 19.2. So this is known. So we can use these scores. And as you can see, so this is less than case. So we are looking at the values less than $80. Therefore, this is left tail test. And the alpha value is given, which is 0.10. So we are going to use this alpha to make the decision of this hypothesis testing. Let's find the test statistic here. The formula for the test statistic Z0 is x bar minus mu over sigma over square root n. X bar is 75 minus $80 divided by 19.2 divided by 36 square root. So the value of this test statistic is negative 1.56. So we have the test statistic value here. Now, as you know, there are two methods to make a decision, critical value method and the p-value method. I'm going to use both methods in this video. Let's look at the critical value method. So we need to find the critical value. Look at the alpha value is 0.10. So we are in the left tail. So this area in the left tail is 0.10. So this cutoff value here is your critical value. To find this critical value, you need to look at the z-score table. Locate this area in your z-table. You will find the closest number is, for the 0.10 is 0.1003. So this is the closest number to this area, and locate the z-score. Z-score is negative 1.2 and the second decimal place is 0.8. So this critical value equals negative 1.28. As you can see, this colored area is your critical region. If any value falls in this critical region, then we reject the null hypothesis. So this is the non-critical region, we do not reject. If any number falls in this region, we do not reject the null, because this area is the non-critical region. And that is the critical value method. And let's look at the p-value. P-value method, we need to find the p-value for this test. P-value is the probability the z-scores less than z-naught. So we are looking at the extreme cases. So this probability is exactly same as if you look at your X bar values less than $80. So that means you are looking at this area. So your z-naught is, here we found it is the test statistic value, which is negative 1.6, negative 1.6. So this value is negative 1.6. So you are looking at the area, extreme cases in this region. So this is the p-value or the area under the curve less than negative 1.56. So you can find this area looking at your z-score tables. Locate this z-score negative 1.6 and the second decimal place is 0.06. And you will see that the area less than negative 1.56 is 0.0594. So that means your p-value is 0.0594. Now we have everything, right? Now let's make the decision. According to critical value, so your critical value is negative 1.28 and your test statistic value, Z0 value is negative 1.56. So which one is bigger? So since both numbers are negative, the higher value will be the smallest number. So as you can see, negative 1.28 greater than negative 1.56. That means your Z0 falls over here, right? Your critical value is negative 1.28, but your Z0 value, the test statistic value is less than negative 1.28. So it's in the critical region. So this is your critical region. So therefore, we reject the null, which is H0. So that is the decision according to the critical value method. And then let's look at the p-value method. So the p-value, we found 0.0594. And we are going to compare this p-value with alpha value, which is 0.10. Which number is bigger? As you can see, your p-value is less than your alpha value. That means if you look at the graph, let's say your p-value is this much in the left arrow. So this is your p-value, which is 0.0594. And alpha is bigger. So as you can see, this is your alpha in the right here, in the left here, right? So as you can see, your whole p-value is less than your alpha, right? It's in the critical region. So therefore, we reject the null. So then let's write the conclusion. So in both methods, we reject the null. So the conclusion is there is enough evidence to support the claim. Claim is in the alternative hypothesis. So we have enough evidence to support the claim. The claim is that the average cost of men's athletic shoes is less than $80. So we have enough evidence to support the claim in this problem. So if you have any questions or concerns about this, please comment. And I hope you understand this problem. And thank you so much for watching this video. If you want to see more videos like this, please subscribe to my channel. Bye.